Hello everyone, my name is Rajesh Kumar and I'm your DevOps, SRE, DevSecOps coach. I have close to 18 plus years of experience working in multiple MNCs around the globe and having in-depth knowledge of DevOps, SRE and DevSecOps. So I would like to introduce you one certification program in a DevOps, and that is we call it DevOps Certified Professional. Now this is a 2 months of program, 25 tools of DevOps you will learn, and apart from that you will also get the access to the LMS, lifetime access to the videos portal. It's a certification program, and you will have 25 assignments and 2 projects along with it. It's a completely weekend program, so here you have classes on Saturday and Sunday. So as part of this course, you will learn multiple things. Here you see that you will learn Linux, AWS, Docker, Jira, Confluence, Python, Git with GitHub, SonarQube, Maven, Gradle, Packer, Artifactory, Selenium, JMeter, Ansible, Kubernetes, Helm, Terraform, Jenkins, Datadog, Splunk, and Neuralink. Now, how do we, apply for this? So how can you reach out to us? So you have a WhatsApp number and email ID. So please reach out to us, and we'll help you to onboard this program. Apart from this DevOps certified professional programs, we are offering other certifications as well in a DevSecOps, SRE, and one of the very comprehensive programs which we have is in Master in DevOps Engineering. Yeah, so feel free to get in touch with us and then enroll for it. Thank you.
Okay, so guys, first question is what is Docker? Correct. So if I look at the Docker, I see that Docker is a container management tool. Okay, so this is the which I see. Now tool means what? Tool means saving cost, right? Saving cost, then saving time also, and improve quality. Okay, so these are the three things you have for the doc: saving cost, saving time, and saving improve quality. But the question is, saving cost in what way? Saving time in what way? And improving quality in what way? So saving cost in terms of when you run application using Docker in container. Okay, remember that when you run applications using Docker in container, consume less CPU, RAM, and operating system and stuff like that. How? This will discussed. So basically, you spend to run applications, you spend less CPU, less RAM, and no operating system cost which you have. So for that, you are saving cost. Saving time means you can run applications. If you remember that in the virtual machines era or physical servers era, you were running application in 5 minutes, but here 1 second, one applications. 1 second, thousands of applications also you can run with the help of container technology. So 1 second, thousands of applications. Saving time here, and whatever the saving time you are doing and cost, you can spend on the improving quality of the software, good quality software, good code, and all. So these are the benefits you can say. So if someone will ask you, hey, why you are using Docker, you can say using Docker we run container. Container consume less CPU, RAM, and no operating system cost compared to the virtualizations and physical server era. Same time, you can create a container, an application, you can run an application within a no time and saving a time. And this will help you to improve the quality. So now the next question is what is the management? Management. So management means here Docker can create a container. Okay, create a container, start a container, stop a container, start a container again. You can restart a container. You can pause the container. You can unpause the container. You can kill the container. And then finally you can remove the container. So all these things you can do through the Docker. That's the reason Docker managing the container. Are you able to understand that, all of you? Hello.
Yes.
So now
Yes, sir.
next question is what is container? Right. This is the most important question what we have. What is container then? So this we need to understand. Okay. What is container? This we need to understand. So let's try
Rajesh,
to understand.
are
Yeah,
you
go ahead.
recording the session?
Yes, this is recording.
Okay.
So what is container? This is the important thing. So now, in order to understand the container, you have to go back in history. So let's understand this is in a simple way. Let me tell you guys, here you require little bit of understanding of kernel to understand the container. So here what happens? Let's discuss about the physical server era. So what happens? In physical server era, we have a hardware. On top of we have operating system, and then operating system give me one network, one process tree, and one root file system. Okay, and then we have one user which you create. You can create multiple users also, but typically when you run a data center, one user is sufficient. You have one user and then one application you are running. Done. So this is the hardware layer. This is the OS layer which has a kernel. Kernel help you to create a one network, and then one bit tree, and then you one root file system, and then one user is there. This is user, and then running applications. Okay, so this is how we run the application in physical server era. Now let me show you in a simple way. So look at this table, detailed one. Look at this table here carefully. So many applications running on my host. See here, this is one application. Chrome is another. This is one. All these applications running. If you look at it very carefully, in order to run applications, okay, there is one PID tree is there. Okay, so if you see that here, there's a one PID tree. Look at it very carefully. This is a one application, let's say, and PID tree always start with a 0, then 1, 2, 3, 4 like that. So here you start 0, and this is the PID of this application. And who's running this application? System, user. So user is required for running an application. And here you have some memory, and here you have a CPU. Okay, so look at this here. In order to run an application, you need a CPU, RAM, user, and applications is located in the file system, root file system. Something like root file system means this will be under the C drive or something like that, right? C drive, Windows, or program files like this will be located. So here the same way, network you need, PID tree you need, root file system. Let me show you the image of root file system for Linux. So root file system means Have you seen this somewhere? All of you? This one? Hello?
Yeah, we
Hello?
can see.
Have you seen this somewhere? Where have you seen?
File path. We can see it in our like the program files inside some software. So we
Yeah.
like this
So this
format. A little bit familiar
Linux,
with bean library. This is a Linux
look
type
at
of
this.
path.
Yes. This is the one. This is the root file system. Here is the root. In Windows also, starting with my computer, this is the one. Here it is. C drive,
So
program files.
mhm.
So what do we call it? Root file system. And then one user and then applications. So this is how applications run. Okay. So this is the physical server era. But right now we are not in physical server era. We migrated to
Rajesh,
virtual server. Yeah, tell me.
yeah, what is Petri? I don't understand.
Hello?
Hello, yes, what is Petri?
Pit tree.
Yeah.
That's a good question. Pit tree means what? So you understand the PID, right? Correct?
No, no,
PID ID. Do you understand PID?
no. I don't understand.
Oh, okay. So what happens when you reboot the system? I mean, when you boot the system, compute unit, there is a one PID tree get initialized. PID tree means 0, then 1, then 2, then 3, 4, 5. Now this is the PID number. Start with the 0. This is running your kernel. This is you, and you are running Apache here. This is the Apache. So every applications which you run, one PID get allocated, like 3, 4, 5. You see that here, PID. See that all these applications running in your machine, and for each PID get allocated, and PID through that only is like a way to identify the process. You get the CPU and RAM. Okay, so this is how the computer works fundamentally. Got it? So pit
Okay,
tree is like this is the we call it pit tree. This is we call it a pid ID. Got it?
okay.
Yeah. So I was discussing one question here. What is container? So in order to discuss the container, I discussing about the physical server era. Okay. And in physical server era, we want to run any application. You need a hardware, operating system, network, PID, one PID tree, and one root file system. Root file system just now I showed you here. Anything start with a root file system is a root file system. So this was a physical server era. Okay. And this is the kernel we have it. But we don't run application in physical servers nowadays. Where we run, all of you?
In a container,
No, virtual servers.
what's it?
So now let's understand a little bit of virtual servers also. So virtual servers. Focus on this guys, very important topic, all of you. If you take it lightly, then you will not understand. So in a virtual server, what happens? There is a hardware and there is a hypervisor. OS, and you have a OS level, let's say OS, and then there's a hypervisor. Okay, so let me, this is the hardware and this is the OS and this hypervisor. Can you please tell me some of the hypervisor software name?
Yeah, VMware, VirtualBox,
VMware, yeah, VirtualBox.
And
Have you
Dockerbox.
installed the VirtualBox?
box.
VirtualBox.
Have you installed the VirtualBox?
Yes.
Yes, I do.
Good, good. Yeah. So hypervisor, and after that, what we have is virtual machines. So let me create one virtual machines, one, then two, then three. Now, if you see that each virtual machines, you have a operating system, OS, again OS, and again OS. You know that OS here. If you see the compare with the last one, after the OS, what we have network, bit tree, root file system, user. So here, this OS will give you this network, this bit tree, this root file system, and this user and application is running. This network, this bit tree, this root file system, user, application is running. This network, this bit tree, this root file system, user, application is running. So this is how we run the application in virtual machine. So now tell me one thing. If you look at this here very carefully, what is the problem in this architecture, in the VM architecture? Do you see somewhere that resources being wastage? All of you?
What was your question?
One.
So in this architecture, look at this physical server architecture I showed you. One server is needed to run one applications. So if you want to run 20 server, then 20 applications you can run it. But we have a virtual machines now. So virtual machines, you want to run three application, you create a three VM, one application, two application, three applications. So you create a three VM. So now, what is the problem in this architecture?
So for one virtual machine, it's using one OS, so it is consuming more space. For
Ah, good observation. So here there is architecture here. What you want to run? Three application you want to run. Okay, three application you want to run. Three Apache, let's say. Okay, so here you have to have three OS actually. One, two, three, four OS. That is a problem. Now mind it here. OS also consumes CPU, RAM, storage, and operating system cost. So what to do? What to do? That is where, you know, that is where few scientists has come up and they said, hey, let's do one thing. Let's change this architecture. Let's change this architecture. So let's design new architecture for running applications. What architecture? So you have a hardware and here you have a operating system, in operating system. And then here operating system, you need what to, in order to run application, what you need resources like, let me tell you, you need one network, bit tree, file system, and user. In order to run any application, one applications, you saw that what you need, one network, one bit tree, one root file system, one user. Are you comfortable so far?
Yes, sir.
Administrator root
Now,
file.
all these resources created by whom? Kernel. Look at this here in the VM model. Here you have a kernel, here you have a kernel, here you have a kernel. Here also too you have a kernel as operating system. And in the physical server era, you have, here we have kernel. So what scientists are suggesting, let's do one thing. This is the operating system and this is the hardware. Let me ask how many networks you can create. So kernel can create. So kernel says I can create as many network. Then he's asking kernel, hey kernel, how many bit tree you can create? And many. How many root file system? Root file system means C drive, something like that in Windows. How many you can create? And how many user you can create? N. Look at this here. You can create all this n number of it. Kernel can create all these resources n number of it. But because of PC concept, PC means it's for designed for human. Okay. So how many network you create by default? One. Pit tree one. Root file system only one C drive. But user you can have n, right? The PC concept, let's say my laptop, one network, one pit tree, one root file system, and n network, n users you can create. So this is something reality in PC. This is a capability can, okay, and need for applications. This is something which we have. So what to do in this case? Now can we do something like this? Look at my screen here. So this is a kernel, okay, and then here we have one common network, then pit tree, root file system, then multiple users will be there. See here, user 1, user 2, user 3, and then applications will run Apache. So Apache is running on 80 port. This user is also running Apache. So do you think 80 port can be run? This user can run 80 port again in the same machine?
No.
No.
Why? Because there's a
Already.
network, one network, one root file system, one pit tree. So here he cannot consume 80 port. Done. This Apache, this user is running on 50 PID. Do you think this user can occupy the same PID number? No, because it will be
No.
different. And this user is running the Apache at this user is running Apache with a C Apache, OPT Apache. This user can run Apache on the same location? No, because only one root file system is there. C Apache only one time. So he has to change the path. But now what is happening? This is the limitation. Why? This is the PC concept. One multiple user. This is the PC concept. So, but how many network, pit tree, root file system, and user can create? Multiple. So, can I ask, hey kernel, can you create one network? Kernel said yes. Hey kernel, can you create? This is the kernel, okay? Can you create one pit tree? Kernel created. Can you create one root file system? Created. Can you create one user? Created. Can you attach this all the resources to this user? Done. So now you tell me, if this user they have their own network, own pit tree, own root file system. So when you run Apache, they're using 80 port from here, this network, 50 PID and C Apache. Because here also you have a C Apache, I mean C drive, here also C drive. Now same thing I will keep asking. Same thing I'll keep asking multiple times. One more, one more, one more. Are you understanding all of it? So directly all this request I'm asking to kernel and kernel is creating it. Understood? All of you? So now
But
the
sir,
question
again,
is, yeah, tell me,
but again, they all are like consuming 80 port number with PID 50. Means
what is that?
like all are using 80 port number with PID 50. It is possible.
It's possible. Why? Because this user, see, this is a user one, Rajesh. This is Neeraj. This is Usha. These three users are using same network. So that's the reason it's not possible. But here this was a separate network, separate network, separate network, separate network. So it's possible. This was root file system. This was one root file system used by all three users. Not possible. But here separate root file system, separate root, separate C drive, separate C drive, separate C drive, separate C drive. So possible. So this user is using these resources, this user is using these resources, but these three users are using these resources, common resources. Are you understanding now?
Okay, understand.
So that is the reason this guy has their own C drive. I'll put it in a root file system, own network, own pit tree. This guy also has their own separate one. This guy also has it, but this guy is not having it. So now the coming back to the question is, coming back to the question, what is container? So guys, container is this one is container. This one is container. This one is container. This one is container. This is the real user. This is the container user. This is the container user. Container user. So all this container user, if you see that, is powered by kernel only. So here, if you look at the compare with the last model, do you have a multiple operating system here? 1, 2, 3, and 4. No, in this model you have only one operating system. So how much time it required to create it? 1 second. So what is container? So functional definition, if someone will ask you what is the container, you can say it's a lightweight application runtime environment. So lightweight means this have no operating system. So consuming less CPU, less RAM, no operating system cost. Application means inside that you run application. Runtime environment means you need network, pit tree, root file system, and user to run any applications. So it's lightweight compared to virtual machines. Now, if you say technical definition, so you say container contain one network namespace plus one pit tree namespace. What is a namespace? It's a part of kernel. One root file system namespace plus one user namespace, and that is combined is equal to one container. Are you understanding?
Yes.
Okay. Now again, in order to understand a little bit more detail, you have to go for the kernel. Actually, you have to study a little bit kernel. But right now, you don't need to discuss whatever I taught you. You don't need to go through that. Whatever I taught you, just go with it in a flow, and that is more than sufficient. Okay. So if someone will ask you, hey, why we are using container? So because of a saving cost in terms of CPU, RAM, and no operating system cost. It saves time also. We can create an application within a container within a second and help us to improve the quality of the software. So what Docker is doing? So Docker is doing creating a container, starting a container, stopping a container, restarting a container, pause a container, and pause a container till the container removed. Now, what is a container? It's a lightweight app runtime environment. You say, can you define a little bit more? So you say, hey, we have a kernel, then kernel we have a uh, kernel, and then kernel create one namespace, one pit tree, one root file system, one user space, and assign that, and that become a container. So that way you have application runtime environment separate, and then don't need a operating system to multiple operating system to run it to run multiple applications. Okay, so this is something which we have it. Now next thing which you should ask, so what is Docker is done. Next thing, let's say if you want to learn Docker, what to do? What to do? So first thing, I will say Docker components. So if you want to learn Docker, the first thing you should install, this is the first step, you should install Docker. Okay, Docker install. So here we call it Docker engine. The Docker is a company name actually. Their first product name is Docker engine. So you should call it Docker engine. But even if you call the Docker, it's okay. So install that first thing. Second thing is download image. Okay. Okay. Third thing, from where? From where we'll download the image. And fourth thing, create a container. That's all. So very simple one actually. See here, download the Docker engine, download image from where, and stuff like that. So how do you install the Docker engine? Guys, you should go to this one and Docker install. If you type it, and here you have Ubuntu, here you have CentOS and all other things. So you can install it. You have sufficient information available. These are the four user to installation. So now I'll just simply install it. It's the one machine. Here Docker is not installed. See, Docker is not installed. Now I'll become a root. Here, normal user, if you use it, you have to use a sudo for using a Docker. But I'll become a root because I don't want to type sudo again and again. So now let me install Docker, and I have to follow this one also.
Whatever you are installing in the server, right?
Yeah, one VM is there,
Okay, we have
which is
server, right?
located. This VM I have created already, so there I'm running that. You can run.
So
You can create a VM
you
in
are connected. Okay, you are connected through the port, right?
PuTTY. Yeah.
Okay.
Okay. So now error, but let me check the Docker is installed or not. Docker is installed. Okay. So Docker is done. Here you see Docker. Enter Docker version. See here 23 version which you got it, and then you can start the Docker system CPU. Start Docker. There's some problem actually. This. So what has happened is there's some problem in it. So I did some machine. This machine is used for something else also. So that is a problem. So what I'll do, I am uninstalling this apt remove, and install this version of it. So to Docker I installed it by mistake, created a conflict with each other, and off fixed. Okay, so now it's done. So guys, Docker is installed. So here, done.
Sir,
Now next
sir,
thing is, yeah, tell me.
what is Docker engine in that? Like,
Docker is a company name, and Docker, when we say Docker install, actually you're installing Docker engine only. Got it?
okay.
So Docker engine is a software, which here if I say no, what is Docker? Docker means Docker engine you are talking about. Actually, Docker is a company. So I install the Docker. Now I need to download the image. The question is, how do we download the image? So what is image first? Guys, let me help you to understand this. You have used a VM image, OS image, right? OS image or VM image. Correct me? All of you? Hello?
Yes, yes, yes.
So, so VM image or OS image contains what? So it contains boot file system. Boot file system means kernel. Then root file system. Root file system means we have Linux multiple flavor of Linux, right? So root file system of Ubuntu, Fedora, Debian, CentOS, Archie. These are the root file system. Here boot file system means kernel, Linux kernel, Linux kernel. And then here we have Ubuntu or CentOS like that. And on top of that, there are some applications are there. Application file system like a root, okay, and then some applications are there. Sorry, user file system is there like a root, and then after that some application is to install Apache, let's say, and then Apache. Okay. So this is the what it contains. In the VM image, OS image, you have a boot file system, root file system, user file system, Apache. So root file system means this is the one, and in Windows program files, Windows is the root file system. User file system means this is the users. Mine is Rajesh Kumar, and this is my file system desktop down user file system. And application file system is Apache application file system. So means I install all of my applications tools. So here this is the JMeter application file system, the folders, files, and also. So this is the OS image, VM image. So you should ask what is in the Docker image, what you have. In Docker image, you have only this one, no boot actually. So please remember, in Docker, you have only this much, no boot, because I said right, Docker image will have a no kernel, no operating system. So these are the three things you have. Got it? All of you? All of you?
Yes, sir.
Okay,
Just
so now,
imagine as like ISO file, right, which is bootable or it's like program.
ISO file for here, VM image, which you have used it for creating an VM. But Docker image will not have a learned kernel. This is a kernel. Boot you will not have it. Root you will have it. User will have it. Application file system. Okay. So this Docker image you have it. Now the question is from where we do we get a Docker image? Download it. This is the one. So we have a registry. What is registry? It's one of the popular. There's so many registries are there. One of the popular registries hub.docker.com. So let me take you to this. See,
Sir, sir, it
the
means registry and hub is the same, right?
registry means the place where we have a repository. Registry means you have a repository, and repository you have a image file system for Docker. Got it? So here if you
Yes, sir.
see hub.docker.com is a registry, and here you see these are the images. How many images you have? Look at this. Now here Ubuntu, if you are reading it, Don't get confused. Here, don't get confused. It is a operating system. No. Here, remember that you have a no boot, only root. So here, when you say Ubuntu, that means you have only this one. But when you say, let's say HTTPD, Apache, then in that case you have whole things. That means some root are there, on top of some user are there, and then on top of some application installed. So when you say Python, some root will be there, some user will be there, then Python will be there, like that. So these all are images.
Okay.
Lakhs of images are there. Got it?
Means the same goes to Ubuntu. It will contain root file system and user file system and the application file system only.
Yeah, application files. No boot.
Yeah.
Okay. So this image, what happens? Understand this. This image, when you create a container, mind it here. This is important now. So we'll download this image from registry. Now you can search that here. HTTPD, all this thing you can search for it. So many images are there. Any images, MySQL image, Java image, Python you want to install in a container, Python image. So a lot of images are there, no problem. But so you understood this. If you want to learn Docker, install the engine, showed you. Then download the image, I'll show you. From where? So hub.docker.com default registry. And then you create a container. So in a container, when you say, what will happen? So this is you send the command to Docker client. Docker client will send the command to Docker D server. Docker D will send the command to container D, and container D, before that, Docker D will check image local. Check image local. If it is present, if not present, download it from the registry hub.docker.com and then send the instruction to container D. Container D will send the instruction to kernel, and kernel will create one network. Okay, one one gateway and then one user. Okay, kernel will create, and then one mount, one root file system, one mount we call it root file system from copy of image, the image which you downloaded. That means this image is equal to root file system, or you can say mount also. Many people say mount or container, okay, from the image. So that means if you create one container, one copy will be from image will be coming. If you created 10 containers, 10 image copy will be there. Okay, so this one
Sir,
and merge this to,
sir,
yeah,
can you repeat it again? I'm not understand this. Create a container.
yeah. So create a container once you have an image. So you send the command to Docker client. So what is a Docker client? Let me show you. Which Docker? This is the client. This guy will send the instruction to daemon. Which daemon? This is the daemon. This daemon will check image. Image is there or not. If it's not there in local, Docker images. Right now I have so many images. So it will check that images. I downloaded last image. So
Sir,
many
Docker,
images are
sir, local. I'm confused about the local and like the
local
where it
means
sends the message.
images you have here, no? You have to download it. So this guy will do that.
Means already downloaded images will be the local or
You can download manually. I'll teach you. Flow, just understand this. Commands I'll teach you. Okay. So Docker D will check the images, and these are the images. See repository. These all are images. Okay.
Which is the client
Means
view?
it is Docker registry, right?
No, Docker registry is here. Okay, let us see. So here, this is the Docker hub.docker.com, and this is your laptop or VM. So you will download this image from here to here, and then you'll get it here. So now which you're seeing is downloaded image. I don't downloaded last day actually, few days ago.
This
Okay,
is
I'll
local,
show
right,
you. This is
Rajesh?
local image. This is local.
Okay. So whatever we downloaded from the hub to the repository is check local image.
Yeah,
So
check local
image.
image. So,
Okay.
so here what I was trying to tell you, when you send a request to creating a container, this all workflow happen. What? You send the commands to client send to the Docker D check the image is there or not. If not, then download it. After that, send the request to container D send the request to kernel, and kernel create one network, one pit tree, one user, and one mount from the image, one copy of image. Okay, so that is what happens, and so on. It's become one container. So container D is utility. Let me show you, which is there when you install the container Docker. See, and kernel you have it anyways. Okay, so now if you see that here, getting confused with so many images already there. So I created few last training. So what I will do, delete this. So nothing great about it. So Docker delete all images. Understand this? Done. So what I did, Docker yes, there's no images right now. There's no container right now. And okay, so I just cleaned up the test environment. Fresh, I can show you that. So again, I'm repeating one more time. If you want to learn Docker, first thing what you have to do, install engine. Then download image. Can I download the image? So I'm going to use one of the image for this training. It's HTTPD, which is easy to understand every person. So now Docker pull HTTPD. Now you'll say, how do I get this command? So here, every image will have that command. See that? Docker pull HTTPD. So now I downloaded image. I'm downloading image from the hub.docker.com. Now if you see the Docker images, see this image is there, repository named with HTTPD, tagged with the latest image ID 2 days ago created, and size is 145 MB. So this is the image. Do you have a container? So running container Docker PS, run all containers, running, executed, created, and all Docker PS-A. No containers right now I'm having. So this is how I downloaded the image, where from where default hub.docker.com, and then I will create a container which it will be doing this one. So this one, you remember that, all of you? Docker will do all this stuff, which I'll show you now. Are you understanding, all of you?
Yes, sir.
So now guys, nothing great about it, very simple. So let me create a container. So I need to follow this one. So first thing, look at my screen. Docker create container. So Docker create from what? HTTPD. You see that I created a container. Every container has a 40 character hash value. How you can identify? But in here you can see shortcut. So PS means it was not showing any container. Why it's not running? Because it's created. But A will show you that container ID, which is shortcut for this image inside a container is running with created, status, and name. One unique name you will be granted for each container. Though if you want to change it, you can do that very well. Let me do that. So I'm creating one container with a name. If I have a name Raj1, and here done. See the last column Raj1, and I created two container. You create another container. So let me remind you how much time it takes to create a container. Only 1 second. See 1, 2, 3, 4. So that so fast actually. So this is a container not running, but all are created. So this, did you understand this now? Hello.
Means from one
Yes, sir.
image
Yes,
we
sir.
can create as many as container, right?
Yes, because I told you, right? Every time each container will create one copy of image and attach to the container. So this is the container ID. Now can I start the container? So Docker start container ID or name, anything you can use it, no problem. Both are unique. And now you see that up. You want to start another one? Docker start. Here, two containers is up and running. Four containers in created state. Now you want to stop it. So you can stop it only running container. So this is the running from last 13 seconds. Docker stop. Enter. See here, exited. Now see that exit result is 0. The exit code is 0. So this container I stopped it, exited. Remember that the container which has run, and then if you exit, then I stop it, then only exit will come. First time it will be created. Then you want to start again that container. So start it, and you see here again it's running. You want to restart it. So this container is running from last 44 seconds. Let me restart it. Restart means stop and start. So here, restart it. And you see here, up 1 second. Now you want to pause it. You want to pause that container. Pause means what? Pause means CPU allocation will not be there. RAM will still be using. So this will be running container, but CPU won't get it. This container kernel will not assign any CPUs for it. You can see that using Docker stats. Look at this. Stats will tell you which container is running and how much CPU they are using it. So here you see there's 0, but RAM they are using it. Here. But like that. So pause container will not demand CPU, will not be allocated with CPU. You can unpause it also. How? Done. Now it's okay. It's running and accessible, CPU will get it. Unpause and pause. Now finally you want to kill it. So let's kill it. Kill the container. Now stop versus kill. So if you stop it, it will be graceful. Kill means forceful. So that's the reason if you see that, if you kill, the exit code is 137. And then finally you can remove it. So any container is not running, you can remove it. So basically all this container you can remove it. This container you cannot remove it because it's running. So let me remove this container. Docker rm container ID. There is one container created, two container, and you see. So guys, did you understand that how do we work with the container? All of you?
Yes, sir. Sir, I have a question. Like the if we have killed the container, then we have again restart that same container or not?
Huh. After killing the container, you can start it again. Yeah, that's not a problem. But after removing, you cannot do anything. It's gone permanently lost.
Okay. Then, sir, what is the
Okay.
difference between kill and stop?
So that's what I was showing you. So if you kill, it will have a exit code 0. Uh, Let me show you. See here. This is I
Yes, sir.
killed a stop. Huh. But if you kill it, you'll have a 137. Means forcefully and gracefully. Got it?
If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.